Hello, good afternoon, everyone. My name is Abraham Estrella. I'm from CE 29, Professor Diane's class. And today I'll be talking about the production of concrete. Basically, the process that goes into making the concrete, um, how it's made, like what are some properties, what goes into like the specifics that goes into making the concrete, and basically how it's formed. Excuse me. In its simplest form, concrete is a mixture of paste and aggregates as well as rocks. Basically, concrete is a mix of sand, gravel, cement, and also the addition of water. This creates a paste. The paste is composed of Portland cement and water, which coats the surface of small and large aggregates through a chemical reaction called hydration. Now, you may ask, what is hydration? Hydration is a chemical reaction in which the major compounds in cement form chemical bonds with water molecules and become hydrates and hydration products. So basically, in hydration, the products are made by the addition of water. This creates a paste. The paste form hardens and gains strength to form the rock-like mass known as concrete. Within this process lies the key to a remarkable trait of concrete. It's plastic and malleable when newly mixed, strong and durable when hardened. These qualities explain why one material concrete can build, such as in the world of today, we can see that concrete builds skyscrapers, bridges, sidewalks, superhighways, houses, as well as dams. All these things are built by the use of concrete. Now, to make concrete, um, construction workers have to keep in mind that you have to have a certain amount of water, a certain amount of cement, a certain amount of sand, a certain amount of gravel in order to make the concrete, because all these things have to be proportions, or else you will have something messed up when the final product comes out. So, the key to achieving a strong, durable concrete rests in the careful proportioning of the mixing of the ingredients. Like I said, you have to mix them proportions. A mixture that does not have enough paste to fill all the voids between the aggregates will be difficult to place, and will produce rough surfaces and porous concrete. A mixture with an excess of cement paste will be easy to place and will produce a smooth surface. However, the resulting concrete is not cost effective and can more easily crack. So basically, adding more cement will make it easy to produce a smooth surface. That's why, like I said, you have to have a proportioned amount of all the ingredients. The quality of the paste determines the character of the concrete. The strength of the paste. Oh, come on. What the heck? Oh, I don't know. Portland cement's chemistry comes to life in the presence of water. So basically, when cement is mixed with water, it starts coming to life. Cement and water form a paste that coats each particle of stone and sand. This is also through the process of hydration, in which a cement paste hardens and gains strength. The quality of paste determines the character of the concrete. The strength of the paste, in turn, depends on the ratio of water to cement. So if there's more water than cement, it's gonna come out liquid. If there's more cement than water, then it's gonna come out smooth. You want like more, you want more cement than water than thing. The water cement ratio is the weight of the mixing water divided by the weight of the cement. High quality concrete is produced by lowering the water cement ratio as much as possible without sacrificing the workability of fresh concrete. allowing it to be properly placed, consolidated, and cured. A properly designed mixture possesses the desired workability for the fresh concrete and the required durability and strength for the hardened concrete. Typically, a mix is about 10 to 15% cement, 60 to 75% aggregates, and 15 to 20% of water. So, like I said, you have to have this much, and this much of each type of ingredient. And although like there's more there's a higher proportion of all the other ingredients, cement and water are like the main things because that's what makes the concrete very durable. Aggregates comprise 60 to 75% of the total volume of concrete. The type of size of aggregate are used depending on the thickness and the purpose of the final concrete product. So they are chosen by their size and their thickness. Soon after the aggregates, water, and the cement are combined, the mixture starts to harden. All Portland cements and hydraulic cement that set and harden through a chemical reaction with water, again called hydration. During this reaction, a node forms on the surface of each cement particle. The node grows and expands until it links up with the nodes from other cement particles or adheres to hydration aggregates. Once the concrete is thoroughly mixed and workable, it should be placed in forms before the mixture becomes too stiff. So, before the mixture, they should be placed it should be placed in forms like before the product is hardened. It should be placed somewhere where it can be workable. During placement, the concrete is consolidated to compact it within the forms and to eliminate potential flaws such as air pockets. You want to avoid air pockets because if you have air pockets when you have your final product and you pour your concrete, guess what's gonna happen? It's gonna crack. Yes. Well, for slabs, concrete is left to stand until the surface moisture film disappears. Then a wood or metal hand flow is used to smooth off the surface. So once it's poured out, there's like a material called a hand float. It's like a wood thing, and it just makes it like smooth. Like you slide it, and it smoothens it out. Floating produces a relatively even but slightly rough texture that has good slip resistance and is frequently used as a final finish for exterior slabs. If a smooth or dense surface is required, floating is followed by steel throttling. Also, during this process, we also have curing. Well, curing begins after the exposed surfaces of the concrete have hardened sufficiently to resist marring. Curing ensures the continual hydration of the cement so that the concrete continues to gain strength. Concrete surfaces are cured by sprinkling with water, fog, or by using moisture-retaining fabrics such as cotton mats. Other curing methods prevent evaporation of the water by sealing the surface with plastic or special sprays called curing compounds. So the whole point when your product is done, you want to make sure you cure it in order for your water inside of your product, inside of your mixture, doesn't evaporate. You know what I mean? Because if it evaporates, then your whole mixture is messed up. Special techniques are used for curing concrete during extremely hot weather. Special techniques are used during hot or cold weather to protect the concrete. Yet, weather can affect the concrete. The longer the concrete is kept moist, the stronger and more durable it will become. The rate of hardening depends upon the composition or fineness of the cement, the mixed proportions, and the moisture and the temperature conditions. All of these things go into how you can maintain your concrete. This is all for today, guys. Thank you everyone for listening. I appreciate it. I hope that you can take something out of this, and see you soon.